Everyone. So to solve the recurrence methods, we had four methods. One recurrence problems. It's like iteration, substitution, subtree or recursion tree method, and then Master's theorem. So iteration is not in our syllabus. So and here in this video, I'm explaining Master's method. Mm. So in the Master's method, the given problem we can looks like a form of a t of n by b plus f of n. So whatever the number here, it will be a, which should be greater than or equal to 1, the b, which will be greater than 1, f of n, which should be greater than 0. So we will be comparing f of n with n log ba. So b value will take from here, a value will take from here. So when after comparison, if both are equal, like f of n is equal to n log bba, then we'll say like t of n is equal to theta of n log ba log n. If f of n is less than or equal to n log ba, then we'll say f of n is theta of n log ba minus epsilon for epsilon greater than 0. So then we'll say t of n is equal to theta of n log ba. If it is equal, we'll take time complexity is theta of n log ba log n. If it is less than, it is theta of n log ba. If it is greater than, f of n is greater than n log ba, then we will say g of n equal to theta of f of n. uh, Before that, concluding this, we will one is t of n is if it is equal n log f of n is equal to n log ba, then t of n will be n log ba log n. If it is less than, then t of n is equal to theta of n log ba alone. If it is greater than, then we are checking for a regularity condition. We'll be checking a f of n by b whether it is less than or equal to c f of n for some c values which should be less than 1. This we'll see with the example. So first example is we have the problem like this. So a equal to 2, b equal to 2. So log 2, 2 equal to, we need to find n log b, n power log b base a, right? So n power log 2, 2, b and a are 2, which is n power 1, which is n. Our f of n, whatever the value here is, should be the f of n. F of n is also n. Both are equal. So as per formula, the t of n will be theta of n log b a log n. And then we know what is b and a applying n power n log n. So we got t of n as n log n. If b and a value is different, then this may be different. The conclusion is theta of n log b a log n. We need to apply b comma a. This problem is f of n is n power 1 by 2 root n, which we can write as n power 1 by 2. Here a equal to 2, b equal to 2. So we are comparing n log ba, which is n power 1, but our f of n is n power 1 by 2. So f of n is less than n log ba. For less than things, we have formula which is f of n will be order of n power log ba epsilon. So here the difference between f of n and n log ba is off. Here it is 1, it is off. No? So n epsilon is n off. So we are saying o power 1 minus 1 by 2. Um, so f of n we have found. Now t of n is, if f of n is less than n log ba, the t of n formula is theta of n power log ba. So n power log ba we know n power 1 of order of n, theta of n. So if it is less than and equal to, we are representing in terms of theta of n. Next sum is example for greater than. If it is greater than, we will represent as sigma format. So our f of n is n square. A and b, n power log ba is equal to n power 1. It's actually power I have written is wrong. N power log ba. So f of n is uh, greater than n power log ba. So which we are writing in terms of sigma. So we need to find f of n as sigma of n power log ba plus epsilon. So f of n, actually we know n square. To reach n square, 1 plus 1 needed. So epsilon is 1, sigma of 1 square n square. The regularity condition formula is a of f of n by b should be less than or equal to c f of n. F of n we know n square. if f of n is n square, then f of n by b is n by b the whole square. We know a and b values. So substituting, we are getting 4. Cancel n square by 2 less than or equal to c n square. If we bring c to this side, like it will n square by 2 less than c n square. When if c in one side and we are bringing all these things, so c is like here it will come as 1 by c equal to n square divided by n square divided by 2. So when we move up, so n square divided by n square by 2, n square n cell will go 1 by 2. So c is less than or equal to 1 by 2. So C, as per our condition, C should be less than 1. It is less than 1, so condition satisfies regularity condition. So T of n will be O of f of n. So we found f of n as n square. So for if when f of n is greater than n log BA, the formula is T of n should be theta of f of n. To find this f of n, uh, in sum we have n square, so we are writing theta of n square. One more example solved by SAR, which is 3t. So here a is 3, b is 4, f of n is n log n. Whatever here is f of log n, it is a, it is b. So we are checking whether n power log b, n power log 4 3. So here log 3 divided by log 4, which is 0.798. So n power log 3 divided by value is 0.79. So n power n log n, we have n power 1, f of n as n log n. So n power 1 will be automatically greater than n power 0.79. So we are saying f of n is greater than, which is case 3. In case 3, if f of, we need to find a regularity condition, which is a f of n by b equal to c f of n. So 3 f of n by 4 equal to less than or equal to c f of n. F of n we know n log n. So, and then here we have 3 f of n by 4. So if f of n is n log n, then 3 f of n by 4 is n by 4 log n by 4. So when we solve all these things, we'll get c as 3 by 4. 3 by 4 is actually less than c, less than 1. Uh, I have solved it in a different paper. If it is confusing, we can discuss in person. So regularity condition holds. So we can say T of n is equal to theta of f of n, theta of n log n. Thank you. If you have any queries, please feel free to reach.